Now, our today's discussion is mean value theorem. Mean value theorem. The first theorem that we will discuss, that is Rolle's theorem. Rolle's theorem. Before the discussion of the theorem, first of all, we will discuss about that. Suppose this is y-axis, OY, OX. Now, although in your previous classes you have gone through the syllabus, but Rolle's theorem, but this is nothing but a recapitulation to all of you. Suppose you have taken 2 points, x equals to a on x-axis and some higher value x equals to b on x-axis. All of you know that all the intermediate points between the interval, here the interval is b minus a. All of you know that all the intermediate points, including the boundary points, can be represented as the closed interval using square bracket a comma b. Now, excluding the boundary points, and only the intermediate points can be taken as the open interval a b. And already all of you know that the conditions of Rolle's theorem the first condition is
function should be continuous.
The function
between closed interval a,
f(x)
continuous and differentiable.
Differentiable in open area.
Function should be
Continuous in
differentiable.
the closed interval a comma b. So suppose
In small interval.
this is the this is the continuous function, and suppose
the b closed interval
this
Close
point,
interval, no sir.
this is f of a and f of b, both are same. F of b, both are same. Now, if this is f of b, and here function is the continuous in the closed interval. Sorry, this is square bracket, and derivable
Derivable in the interval
in the open interval
In open interval a comma
A
b.
and b.
and the third condition will be
F is equal to
F equal to b.
A is equal to AB.
a equals to f of
b.
b. Then there must be some point C within the interval
F dash
where
is equal to 0. C equal to 0.
f dash
Zero
C
and
equals to
if C has the highest,
how can
C lies between A to B.
how it can be proved? As first of all, as the function is continuous, so it is bounded, and somewhere at the point, suppose C, the function attains its maximum value. You just assume the maximum value is capital M. Okay. If it is constant, then f dash c is 0. If the function attains its maximum value capital M at the point C, then if you go limit h tends to 0 plus or limit h tends to 0 minus, if you go in both left hand side or right hand side, in both cases the f of a plus h is less than equals to
F of C.
sorry f of c plus h f of c. Now if this is
Sir,
true,
voice is not clear.
uh, okay, but this is some internet problem. F of c plus h, if f of c plus h minus f of c, if it is less than equals to 0, then if you divide it by some positive quantity like limit h tends to 0 plus f of c plus h by f minus f of c, suppose it is less than equals to 0. If it is h tends to 0 minus,
then
then
it
it
be
is
positive.
greater than equals to 0. So obviously, so we can conclude that. So we can easily conclude that L of f dash c r of f dash c f dash c, that is equals to 0. And if it is constant, then it is f dash c equals to 0. If the function attains minimum value f of c equals to small m, then the same procedure you just follow and you can prove that the function at, at the particular point c f dash c equals to 0. So it can be proved. Next thing that has to
Sir,
be discussed.
sir, can
Yes.
you explain after the maxima part again?
Suppose this is the point C. Suppose this point function attains the maximum value. Then if you go right hand side, function value is less.
Yes, sir.
Either less or, as you have assumed, either less or equals. If you come to left hand side, then also less or equal. So f of c plus h is a quantity which is less than equals to f of c, because you have assumed f of c is maximum, that is capital M.
Yes,
So
sir.
always f of c plus h minus f of c, it is less than equals to
0.
0. Now if you divide it by some positive quantity, it is total quantity will be less than equals to 0. If you
Yes, sir.
divide it by
Yes, sir.
negative quantity, it is greater than equals to 0. That is
Yes,
only
sir.
possible that f L of f dash c equals to R of f dash c equals to f dash c, that is equals to 0. So Rolle's theorem is proved. Clear?
Yes, sir. Thank you.
Yes, sir.
Yes, sir.
Yes, sir.
Next portion that I want to discuss, that is, suppose if a problem is given to you,
Sir,
suppose f of x is given to you, that x minus a to the power m, x minus b to the power n. Then if the interval a less than equals to x less than equals to b, then within the interval you just prove that there is a point c which divides the interval with ratio m is to n. That we have to prove. Then first of all, you just consider this quantity as u, this quantity as v. So f dash x can be derivative of the first. So it
Sir,
can be
please
written
can
as,
you explain your question once again?
okay.
So what is that m is to n?
Yes. Here this proof, I have considered that this is the interval. B is some higher value, A is some lower value. Okay. Then interval is B minus A. B minus A. So if you consider the boundary points including, then it will be a closed interval AB. All the intermediate points and the boundary points and AB. Now, as the function is continuous, function is derivable, then the function attains a maximum value, suppose capital M, at a certain point. Suppose you have considered C is a point where the function attains its maximum value. So if you go right hand side, if you go left hand side, function value is less. Function value is less. So
Yes, sir.
f of C is maximum, and if you go C plus H, either it is less than or equals to f of C, because you have assumed f of C is maximum. So f of C plus H minus f of C is a negative quantity, either negative quantity or 0. And if you divide it
Yes.
by negative quantity, like 0 minus, H tends to 0 minus or H tends to 0 plus, in both cases, it will be either total f of C plus H minus f of C by H. It will be either greater than equals to 0 or less than equals to 0. So both right hand side, left hand side, and at the particular point, so it is f dash C equals to 0. This is the proof. Okay.
Yes, sir.
Thank you, sir.
Next the question is that the interval is A to B. Now, for this particular function, using Rolle's theorem, you have to prove that it divides the interval with ratio m is to n, and you get a point C, so that f dash C, and at the point C, it will divide the interval AB with ratio m is to n. In that case, at first you have to find out f dash x. What is f dash x? You have considered x minus a to the power m as u, x minus b to the power n as v. So derivative of u, m x minus a to the power m minus 1
minus 1
M minus
and
1.
into x
x minus b to the power n unchanged,
yes, sir.
plus x minus a to the power m and n into x minus b to the power n minus 1. Then this will be, and from these two
0.
quantities, how, what will be the maximum that you can take common? Here x minus a to the power m minus n minus 1.
X minus b to the power of n minus 1.
So you can take common x minus a to the power m minus 1, x minus b to the power
Or
n
n
minus
minus
1. And the quantity that is remaining, m into x minus b,
yes, sir.
m into x minus b, plus
n
n
into
n
x
into
minus
x
a.
minus a.
A.
Next, if this is only remaining, then you can easily write, just 1 minute. Okay. Now here, if you write that m into x minus b plus n into x minus a, if it is equals to 0, then mx minus mb plus nx minus na equals to 0. So you can easily write that x into m plus n, that is equals to mb plus na. So x can be written as mb plus na by m plus n. Now if this is the point C, then C divides the interval with ratio m is to n. Okay.
Yes, sir.
Yes, sir. Yes,
Okay.
sir.
Yes, sir.
Okay, sir.
Sir, why do you
Next.
think it's zero
Yes,
because
sir,
of
understood.
Yes, sir.
Next. Next is
Sir,
hmm,
sir, I have one doubt.
oh, at last I shall talk. Okay. At last 10 minutes, I shall talk.
Hello, sir.
Mm-hmm.
Hello.
Tell me.
Sir, why you equal to 0 in the equation?
Because this is a product of these two. This is a product. Just previous 1 minute. This is a product of these two, na?
Thorough.
Sir, excuse me, sir.
Hmm.
Sir, your video is not showing on my PC, sir.
Oh, it may be some your problem.
Network problem.
Now you just, this is a product of m into x minus b, because this is a product, no? This term is product multiplied with this quantity. So either this will be 0 or this will be 0. Now you have taken this will be 0 and you have proved. Okay.
Okay. Sir, x is equal to a or b or MB.
Okay, I shall discuss it at last.
Sir, can you say the picture again? The graph.
This.
Yes, sir.
Okay.
And just below side.
Sir, one doubt, sir.
Mm-hmm.
Okay, sir.
Sir, now we are taking f dash of x equals to 0, no, sir. Can we conclude that f of x is a constant function?
Yes, there are good question. Good question. There are three cases. F of x may be a constant, then automatically it will be 0, na? It will be 1 minute.
But sir, can a constant function can divide the two?
No. There are three cases. This is one case. This is one case, na? This is one case I am showing. I have shown. There may be other cases. There may be also other cases. You can take the minimum value, small m, and you can prove it. Okay.
Sir, can we take x is equal to a?
There are several cases. I am just last 10 minutes I shall discuss. Now just I have to complete the syllabus. Na? Okay. Now the next theorem, all of you know, that is Lagrange's mean value theorem.
So, there are few people in the waiting room. Can you let them in?
Okay, just they will get the video, na? Okay. Lagrange's mean value theorem. What is Lagrange's mean value theorem? Anyone?
F of A
Fx is continuous.
F of x is continuous. Close interval is comma
And
b.
differentiable in closed interval
A to
a
B.
to b.
A to B.
Sir, it is used to find out the slope.
Differentiable in open
Fx is
interval.
differentiable in the open interval. Yes, correct.
Closed
Sir,
interval.
not yet.
But the last condition is not given. The last condition of Rolle's theorem is not given here.
Not given.
Okay. Then question is that
Rolle's theorem is extension of Lagrange's mean.
Sir,
then suppose this is OY, this is OX. Now,
सर सर प्लीज सबको म्यूट करने के लिए बोलिए, कुछ
हाँ।
समझ नहीं आ रहा।
हाँ सर, कुछ समझ नहीं आया।
Yes, sir.
सबको म्यूट करने के लिए बोलिए सर प्लीज।
सब म्यूट करो।
आप ऐसा कर दीजिए कि कोई माइक नहीं ऑन कर पाए, ऐसा कर दीजिए आप।
Then how we can ask my doubt?
Like in the
And you can ask your doubts.
Ask your doubt
at
last 10 minutes.
Yes.
That is problem to my problem.
अच्छा आप बोल दीजिए.
Okay. Now here, if in Lagrange's mean value theorem, the last condition of Rolle's theorem is not given, and here fx is continuous in the closed interval, fx is derivable in the open interval. So if you consider x equals to a and x equals to b, 2 points, and suppose this is the value of the function x equal at the point x equals to b, and this is the value of the function at x equals to a, and suppose this is the function y equals to f of x. Now here the interval is b minus a, and this will be the value f of a. This will be the value. Suppose this is the extension. This will be the value f of b. So the difference or the increase of the function will be f of b minus f of a. Then the average increase of the function will be the increase of the functional value by the interval b minus a. So Lagrange's mean value theorem tells that there must be some point within on the particular function where the mean increase is equals to the increase at that particular point. So you can easily write f dash c equals to fb minus fa by b minus a. Now here in this particular proof or in this particular theorem, you have seen that the last condition of Rolle's theorem, that fb equals to fa is not given. So how this Lagrange's mean value theorem can be proved? First of all, suppose you have taken a function phi x equals to fx plus capital A is a constant into x. Now here the assumption is, as fx is continuous, phi x is continuous. As fx is derivable, phi x also derivable, because it is only the constant into x. And the last condition as not available in Lagrange's mean value theorem, here your assumption is that you have to supply the value of a, the constant value. Your assumption is that you have supplied the value of a in such a way such that phi a equals to phi b. Then phi x satisfies all the conditions of Rolle's theorem, because as fx is continuous, phi x is continuous, fx is derivable, phi x also derivable, and the last condition of Rolle's theorem, that is phi a equals to phi b, according to the assumption that you have taken the value of, or you have supplied the value of capital A in such a way so that phi a equals to phi b. Now you have to prove that the Lagrange's mean value theorem. Now as phi x satisfies all the conditions of Rolle's theorem, then you can easily write that there must be within the interval a point c so that phi dash c equals to 0. Now already you have assumed that phi x as f of x plus capital A into x. Now if you write that phi dash c, suppose phi dash x equals to f dash x plus capital A, as it is a constant x derivative 1, so only capital A. This is equals to 0 if at the point c. So f dash c plus capital A equals to 0. So f dash c, sorry, f dash c equals to minus of a. This is proved. Next, you have assumed that phi a equals to phi b. Then you can easily write that f of a, because this is phi a, put in this equation a, f of a plus capital A into a, f of a plus capital A into a equals to phi a equals to phi b. So f of b plus capital A into b. Now here you have seen that fb minus fa or fb minus f of a taken this side, then it will be capital A into a minus b. Now here you can easily write that minus a equals to fb minus fa by b minus a. Here f dash c equals to minus a. Here minus a equals to fb minus fa by b minus a. So you can easily write that f dash c equals to fb minus fa by b minus a. This is the proof of Lagrange's mean value theorem. Next point that I have to discuss, that is some problems belongs to this particular category, and this is very much important concept that is required to all of you for solution of problems of mean value theorem. Before, just 1 minute. Here suppose this is y-axis and this is suppose x-axis. Now you have taken x equals to a, so this length is a. Now this point is x equals to b. This concept is very much important for solution of problems, subsequent problems that we will discuss. Now here see, b is some higher value and the interval, this is b minus a. You have just assumed that this interval b minus a is small h. Then the intermediate point, how you can represent? The intermediate point will be length of a plus b minus a into a quantity which ranges between 0 to 1. So you can easily consider that the intermediate point, any intermediate point x can be represented as a plus theta into b minus a, that can be written as a plus theta into, as b minus a is h, where theta ranges between 0 to 1. Theta ranges between 0 to 1. Now you have to apply this concept. We have to apply this particular concept for solutions of different problems. Basically, Lagrange's mean value theorem is used to perform some numerical approximations. Now here, suppose you will be given with a problem that root over of 101, you have to prove it is less than 10.05 using mean value theorem. Now, first of all, this type of, in order to perform this type of numerical approximations, you have to assume a function f of x just similar to it as root over of x. Fx is root over of x. Now here, now you have to concentrate on which will be the interval AB. What will be the interval AB you have to take to perform this type of numerical approximations. You have to perform this numerical approximations to start it from some known value. Suppose root over of 100 is known to you, and root over of 101 you have to approximate that this value is less than 10.05. In order to do this, you can easily write that B is here 101, A is here 100. So B minus A or H, that is equals to H, that is equals to 1. Now here you can easily apply this particular formula, that is as f dash c here a plus theta h intermediate point equals to fb minus fa by b minus a is h, so h. So you can easily write that h into f dash a plus theta h, just multiply it, equals to fb minus f of a. So it can be written as fb can be written as fa plus h into f dash a plus theta h. This is required for this type of numerical approximations. Now here you just apply the concept to approximate the value. Here you see that when you perform this numerical approximation, so fb equals to f of a plus h into f dash a plus theta h. Here a is 100, b is 101, that you have to approximate. H is 101 minus 100, that is 1. If test a plus theta h, that will be 1 by 2 root a plus theta h. 2 root a plus theta h means 10 of a plus theta h. You don't know, some intermediate point. Now here, if it is true, then obviously it will be f of a root over of 100, that is 10. 101 minus 1, that is 1. So 1 by 2 root here 100 plus some value. So this must be always f of b. Here you see, if you increase the denominator, total value will be decreased because this is added 10 plus this quantity. So obviously f of b or f of 101 or root over of 101 obviously less than 10 plus 1 by 2 into 10, because if you increase theta, so always it will be less than 10.05. Okay. Up to this, anyone any problem?
No,
Sir,
sir.
please
Sir, can you
come again.
Yes, sir.
the last explanation part, sir?
Last
Last
part I could not
question.
understood.
Last part didn't understand.
After calculating the every
Explain
value,
again, sir.
explain.
Okay, okay,
Yes,
okay,
sir.
Sir, please explain numerical approach.
okay, okay.
सर लास्ट
So जो न्यूमेरिकल आपने किया है वो एक बार फिर से बता देंगे.
यस सर न्यूमेरिकल फिर से बता दीजिए.
Sir, is we got a problem like comparison only in this concept?
In proof of mean theorem, we have chosen phi a equals to phi b. Why?
Yes, good question. First of all, I am giving your answer that phi x you have considered as fx plus capital A into x. We have considered that fx is continuous, phi x is continuous. Fx is derivable, phi x also derivable. So first two conditions is applicable from the previous conditions of Lagrange's mean value theorem. Then your question is why phi a equals to phi b.
So that
Here
we can apply Rolle'S theorem.
yes. So that you can apply Rolle's theorem. You have assumed that the capital A, it is in your hand. The condition you may change. You have assumed that you can supply any value capital A. You have assumed that you have supplied capital A in such a way so that phi A equals to phi B. So that phi x satisfies all the conditions of Rolle's theorem. So phi dash C equals to 0. Okay, this is your answer.
Sir, in last
And the
last slide, sir.
last slide, that is
Numerical
the
problem,
numerical approximations.
Yes.
What you have done? That root over of
Sir, please
1.
open that slide, sir.
Proof. Please make me understand your proof, sir. Of last slide.
Acha.
Open that.
Oh, acha. This.
Yes, sir.
Acha.
Down, sir.
Yes.
Yes, sir.
Here, this is the assumption that's phi x. Now here, you have considered that phi x satisfied all the conditions of Rolle's theorem and phi a equals to phi b. You have taken the value of a in such a way. So that phi a, what is phi a? F of a, in place of x put a, in place of x put a. So f of a plus capital A into a. Okay. Phi b will be f of b plus capital A into b. Now, if you assume that phi a equals to phi b, then obviously that
Sir, the choice of function should be such that both at A and B point they will be same or disappear.
yes. Then you have just equated that phi a equals to phi b. Similarly, you have calculated the value of f dash c. You have calculated the value of f dash c as well as you have calculated the
We
value of
got it, sir.
Sir,
That question of approximation.
Theorem.
Sir, that question of approximation, there you have
Sir,
written a
explain the
line.
approximation questions.
Okay, next question. Next is root over of 101. What you have done? You have first of all assumed that f of x is root over of x, just similar to the value that you have to calculate. Okay. Then if you consider, then you have to fix what will be the interval of AB. You have to start from some value that is known. So 101 you have to calculate. So root over of 100 is known to you, that is 10. And you have to calculate f of b, that is f of 101. How it can be done? It will be f of a plus h into f dashed a plus theta h. This is the formula. So it will be 10 plus h is 101 minus 100, that is 1. So 1 by,
How does this formula come, sir?
yes, x to the power half x to the power minus half. So it will be
Sir, how
1
this
by
formula
2 root
comes, sir?
f dash a plus theta h. Yes, yes.
Sir,
Sir,
f of
please.
101 is equals to fa plus h into f dash a plus h
A
plus
plus
theta
theta
h.
h. Yes, yes.
How does
How
it come,
Where
sir?
it is come?
How does it come?
Now
Oh,
where this have been
okay.
derived?
Okay.
It's Lagrange mean.
This is the problem.
Mhm.
Yes, sir.
How have you
How
written?
does it come? Yes,
Yes, sir.
good
Yes,
question.
sir.
So f dash
Suppose,
is equal to fb minus fa by h.
that I am saying. Yes, good question. Suppose this is y-axis, this is the x-axis. This is the point x equals to a. So this length is a. Clear? Now you have taken higher value x equals to b. So the interval is b minus a. Okay. So the intermediate point, any point, this point, this point, this point, can be written as the length of a. Suppose this is OA. This is, suppose capital B. This is capital A. This is O. So OA plus any fraction of AB length. This length. Is it true or not?
Yes, sir.
So it
Yes,
can
Yes,
be
sir.
sir.
written as, so intermediate point can be written as A plus theta into B minus A. B x equals to B
Yes, sir.
equals to A. So it can be written as A
Sir, once
plus,
repeat.
yes,
Sir,
yes.
once more.
This length is B minus A because this point is
Sir,
x equals
once
to A.
more. Once repeat it.
Acha.
Sir,
Hmm.
once more.
Hmm. This point is x equals to A. This point is x equals to B. B is higher value. X is some lower, A is some lower value. So the length of this interval is B minus A. Okay. And as this is x equals to A, so this length is A. Okay. So intermediate point, any intermediate point within the interval, suppose the intermediate point, this is the intermediate point, this is the intermediate point, this is the intermediate point. Suppose intermediate point is represented as x. So x can be written as the length of A plus any fractional value between 0 to 1 into B minus A. This length is B minus A. So you have
Yes.
to add it. Okay. So if you
Yes,
can
sir.
multiply it by theta, suppose A, length of A plus theta into B minus A, this length. Okay. So A plus,
Theta must be 0 to 1.
yes, theta into B minus A. So A plus theta into B minus A is, you have assumed as H. So theta ranges between 0 to 1.
One.
That's I have said. Then you have to apply the concept of Lagrange's mean value theorem. Lagrange's mean value theorem tells that f dash C is an intermediate point, C is an intermediate point, equals to fb minus f of A by B minus A. Okay. Now you have assumed that B minus A is equals to H. So
Yes,
you
sir.
can easily write that H or H into f dash C, that will be fb minus f of A. Okay.
We got
Now
it, sir.
C is an intermediate point here. So H into F dash A plus theta H. A plus theta H. That will be FB minus F of A. Now, if you
Sir,
take
I have a question.
F A in this side, you will get that FB equals to F of A plus H into F dash A plus theta H. Clear?
Yes, sir.
Sir, we got it.
Clear.
Yes, sir.
Okay.
Question, sir.
Now, yes, one.
Yes.
No, understood, sir.
Thank you, sir.
Okay.
Yes, sir. Clear, sir.
Now we will discuss the numerical approximations.
Sir, a
Here,
question.
tell me.
Sir, can we get exact numerical value of any number root?
Here, using mean value theorem, you have to approximate the range because it is an interval, na? Because you have to consider one interval, na? So as you have to, one interval is available to you. Suppose 100 to 101. This interval is available to you, and you have to approximate what will be the highest value. Now, at the time of obtaining the highest value, you have to assume one thing. Suppose here in this particular numerical approximations, you have used the formula that FB equals to F of A plus H into F dash A plus theta H. Now here H is 101 minus 100, that is 1. And F of A is root over of 110 plus H is 101 minus 100, that is 1, into F dash A plus theta H. So x to the power half. So half x to the power half minus 1. So here 1 by 2 root. Then you have to think about the quantity. Here you have to remember one thing. If the denominator increases, this is the addition of 10 and some value. If you increase the denominator, then total value will be decreased. Total value will be decreased. So here A plus theta h, that will be 100 plus theta h. So theta into h. So 100 plus theta, h here is 1. Now here, if you put the value of theta, this will be some lesser quantity because denominator will be increased. So highest value that cannot be attained because theta is added. So it will be always less than 10 plus 1 by 2 into 10. Because if you
Sir,
increase
one
it,
question, sir. Sir, how that half into root over 100 plus theta came? That please explain once more.
yes. F dash A plus theta is A is here 100. Okay. Theta is 1. Theta is 0 to
1.
0 to 1.
Between
H is 1. Okay.
Yes,
So 1 by 2 root 100 plus theta. You don't know what is the value of theta. But you
No,
have to
sir,
put,
his doubt was means he didn't understand the differentiation, sir. You had to take root or a plus theta. You're differentiating that, no, sir. You're differentiating root or a
From
plus
there
theta.
it comes.
Because Sir has taken f of x
From
equals to
derivative
root
of
x.
root x
F
is
equal to
perfect.
root
That's it.
x. Root x.
Yes, sir. Yes, I understood.
That's the he didn't.
you have to differentiate root x. But you have not put, but you have to put the value of theta. Okay. So this cannot attain this particular value because denominator is least when it is 100. But you have to increase it. So denominator is increased, total summation will be decreased. So always it will be less than 10 plus 1 by 2 into 10. 10. Now you have understood? Always it is less than.
Yes, sir.
Yes, sir.
Sir,
Excuse me, sir. Sir, I have a
Sir,
doubt.
sir,
Sir,
sir, theta value will be given in the
sir, I have
question.
a doubt.
No. Theta always assume that theta you have to assume that 0 to 1.
hello, sir.
Sir,
Sir,
can
Excuse me,
you
sir.
find
Sir,
derivative
Sir.
approximation?
I have Sir, I have a doubt. What
Tell
is
me doubt.
in
Sir.
the previous proof you proved that in proof of mean value theorem, what is A stands for?
A is the initial point of the interval, B is final point of the interval, and interval is B minus
capital A, maybe.
Yeah. Oh,
Capital A is a constant.
yes, capital is a
This is
constant.
in our
Capital
hands.
is a
Yes,
constant.
capital A,
Yes,
capital A, capital A.
constant. That you
Hello,
can
sir.
supply. You have the freedom to supply it. Okay.
Sir.
Hmm.
Sir, in these questions, if we consider fx is equal to 10.05, x is some point. If we consider, then where is x come from? In between A to B interval or
No,
outside
it
the
will
interval?
not touch. It will not touch this particular value because you have to put theta, na?
Okay. Means
It
you
will
are
not touch the value. Yes.
means you are means
Lesser
you
than
are
this value. It always lesser than this value.
means you are so that if 10.05 where can appear is either above the interval or in between.
This will be the higher value in between. In between. This is the
hoga to,
highest.
sir.
Sir,
It
can
will be
you please
given
stop
in
the
the
emoji
question.
section?
It will be given in the question that what will be the interval, either it will be greater or less, that it will be given. Suppose another question, suppose cube root of 28, that you have to assume. Cube root of 27 is known to you.
Small a
Then
equal to yes 3.
Sir, why you are assuming A to be 100? We can also assume to be 81.
No, the nearest value.
nearest
value.
Nearest value.
Nearest root
The
that
smallest range possible.
that you have to assume from the question. Suppose it will be 10.05, then you have to start from 10, 100 means
Go
100.
to the NCRT. Go to the NCRT of
Sir.
class 12. You will get approximation there.
Sir, can you disable this one, sir? Emojis, sir, too much.
Sir,
Can't
Sir,
even
emojis, please
understand.
disable, sir. It is disturbing too much.
I am going out of time.
Everyone sending.
9:48. Okay. Then
Sir, will you upload this notes on video, sir?
Can we use diagrams to solve, or you can suggest
When you
any batch?
So can I upload
Sir,
this?
can you give an example
Hmm.
like this so
Like,
that we can understand this well?
okay.
Sir, mute all of them.
Excuse me, sir.
No, bro.
Sir,
Let
what
them
will
unmute
happen
it.
if we assume it as cube root of 29?
yes, you can assume, but you have to see that what you have to prove. That
Sir,
will be
please tell
given.
the reference book for
And
maths.
we will consider fx
Suppose,
equals to x to the power 100.
1 minute.
Sir, can you give an example?
Yes, I am giving one example.
Sir, please tell one reference book for maths. This one.
Mighty Ghosh, you can follow.
Okay, sir.
Sir, recording will be available now, sir, in chat section.
Okay. Now, just I am giving another example. I am giving another example. Suppose you have to prove that cube root of 28. Now, cube root of 27 is known to you. Then you just consider the interval A is equals to 27, B is equals to 28. Then you can easily write that f of 28 is equals to f of 27 plus h 28 minus 27 into f dash 27 plus theta. H is here 1. This will be the formula. Okay. Is it clear to all of you?
Yes,
Can you?
yes, sir.
Yes, sir.
Sir, can you
Yes,
show the
sir.
slide
Yes.
again?
Sir, can you
Class
upload the
session.
PDF of this class notes?
Sir, can you repeat?
Yes, already I have uploaded. I have uploaded it.
Yes.
Through MS Teams, I have already
Sir,
uploaded.
already uploaded the PDF.
I have already uploaded the class. Okay.
Yes, sir, but some of
Sir,
the
can you?
new thing also coming there.
Sir, show the
Hello,
slide again,
Kishan.
please.
Sir, can you show the last slide?
Hello.
Already I
And
have
the
uploaded
recording
the total
also.
material. I have
Show
already
the screen.
uploaded the total material
Can you show
to
the
you.
slide?
Okay.
Sir,
Complete material
please
is
explain the
uploaded.
Rolle's theorem too.
Everything is uploaded. You just go through that. Notes
Where
is
the
uploaded.
uploaded,
Okay,
sir?
yes,
Through
okay.
MS Stream already it is
Sir,
Okay,
uploaded.
sir.
please explain the
And
Rolle's
the video
theorem.
lecture, sir.
Sir, can you
And
show
the
the last
recording of
slide?
this class.
Yes, sir.
Can you show the last
Thank
slide?
you, sir. Bye, sir.
Sir,
Hello.
can you use the same
Thank you, sir.
formula for
Yes.
28 to the 1 by 5?
Sir,
F of 28, F of B is F of A, F of 27 plus B minus A, 28 minus 27. This is 8 into F dash A plus theta
Sir,
into A.
attendance.
No attendance is not required. I shall upload it of everything through MS Team. You just go through that, then it will be clear to all of you. Okay.
Okay, sir. And
Sir,
recording also na.
sir,
Recording also you will get through MS Teams.
Okay,
Sir,
sir.
can you leave
Thank
the
you, sir.
class?
Thank you, sir.
Sir,
Okay, sir. Thank you,
sir,
sir.
can you use the same
can we
formula
take
for 28 to the 1 by 5?
Can we leave the class?
Yes, sir.